On simple interest and on compound interest, we can either borrow money or invest money. If we borrow money, we pay interest. If we invest money, we earn interest. When you make an investment in an account that earns compound interest, interest is periodically calculated and added to the account balance. This allows your investment to earn interest on interest, and you earn more money than in a simple interest account. The formula for the future value of compound interest is A, the future value or the amount at the end of the investment, equals P, the principal or the original amount, times the quantity in parentheses 1 plus R over N raised to the NT power. Well, R is our annual interest rate, T is our time in years, and N is the number of compounding periods per year. If interest is compounded annually, N is 1. If interest is compounded semi-annually, N is 2. Interest compounded quarterly, N is 4. Interest compounded monthly, N is 12. Let's do an example. Calculate the amount of money in your account at the end of 8 years if you invest $2,300 at 4% annual interest if interest is compounded semi-annually. Okay. We're trying to find the amount in the account at the end of the investment. So we're trying to find the future value, or A. We're talking about leaving the money there for 8 years, so T is 8. What are we investing? P is $2,300. We're getting an annual interest rate of 4%. And interest is compounded semi-annually, so N is 2. Now we're investing money, leaving it there for 8 years, and we're earning compound interest, so we need to use the compound interest formula. A equals P times 1 plus R over N to the NT power. Now we're trying to find the amount in the account at the end of the investment, so we're trying to find A. We know that we are investing $2,300, so P is $2,300 times parentheses 1 plus 0.04. Now interest is compounded semi-annually, so N is 2. And this is raised to the parentheses 2 times a year times T is 8 years. Now we're going to be able to type this directly into our calculator. So we take 2,300 and then open parentheses 1 plus 0.04 divided by 2, close parentheses. Now raised to the, our raised to or exponent key, our power key, is right above the division symbol and right below the clear button. This is the exponent key. Now you've got to put parentheses around your 2 times 8, otherwise your calculator will give you the wrong answer. Now when we hit enter, the calculator is going to calculate in one step, A, the amount at the end of the investment. And the amount of money we have at the end of this investment is $3,157.41. So the compound interest formula in one step, when you know what you invest and the rate, the number of years, and how often interest is compounded, the compound interest formula will calculate the amount at the end of the investment. Now sometimes there is a follow-up question, and the follow-up question is, okay, how much interest did you earn? Well, to figure out how much interest was earned, we know the amount at the end of the investment, and we know the amount that we originally invested. The difference of these will be the interest earned. Interest is the amount at the end of the investment, $31,57.41, minus the original investment, $2,300. So $3,157.41 minus $2,300. We have earned $857.81. $2.41 in interest. This particular example, we knew the investment, the principal, and we wanted to find the future value or the amount at the end of the investment. Our next example turns the question around. Sue wants to create a college fund for her nephew, Paul. How much must Sue invest today if she wants the fund to be worth $160,000 in 18 years? Assume Sue can get 5.25% annual interest compounded monthly. So Sue's wanting to make a lump sum investment today in an account, leave the money there for 18 years. She can get 5.25% interest compounded monthly. So the big question is, what does she need to invest today? Well, if the question is, what does she need to invest today, we're trying to find P. Now, what she wants the fund to be worth in 18 years, that's the future value. That's A. Of course, T is 18 years. Our annual rate, 0.0525. And for compounding monthly, N is 12. So our compound interest formula, A, the amount at the end of the investment is going to be $160,000. Equals P, the thing we're trying to find, what she needs to invest today, times 1 plus 0.0525 divided by 12 because we're compounding monthly, raised to the parentheses 12 times 18 years. Now what we're going to do is take what's inside this box and type it into our calculator. Open parentheses. 1 plus 0.0525 divided by 12, close parentheses, raised to the open parentheses, 12 times 18, close parentheses. When we hit enter, we get this number. Now, what we have is 160,000 equals P times this number. Do not round this number. This is not the final answer, and you never round on intermediate steps. So what we have is 160,000 equals P times 2.567515814. Now we want to solve for P, so we're going to divide both sides by this number, 2.567515814. Now you can type 160,000 divided by 2.567515814, or what I'm wanting to do is divide 160,000 by this answer in my calculator. So a nice shortcut on my calculator is I'm going to take 160,000 divided by, now again I'm trying to divide by this previous answer. I'm trying to divide by what's the last item in my display. And that's my previous answer. Right above the negative key in yellow on my calculator is A and S. So if I push the second key and then the little negative key, I'll have A and S show up. So my calculator is going to take 160,000 and divide by the previous answer, divide by that previous output. Now, we're trying to figure out what Sue needs to invest today in order to be sure and have $160,000 18 years from now. We talked in a previous video about when you're trying to figure out what to invest today, if there are no specific directions in the computer homework, you should always round up when you round on your cents, just to make sure you'll have the $160,000 in 18 years. So Sue needs to invest $62,317.05 in order to make sure that she'll have $160,000 for Paul's college fund when he turns 18 years from now.